Welcome back. So today we are dealing with mathematics, and this is one of the course outline. Okay, under maths you have about 7 to 8 topics. I get me, and this is one of the topic which is indices, and you will come across a lot of questions during your test and exam under this topic. I getting it. Now let's start from laws of indices. Now let's start from laws of indices. I get it. Now laws are very important when it comes to mathematics because all the equations you'll be solving, like all the complex equations, all the hard equations you'll be solving, you need to understand laws in each topic. I get it. So these laws will help you to solve complex equations. I get it. So let's start from the laws of indices. Now under indices, you have about 7 to 8 laws of indices, and you have to understand each of the law. Okay, so from the first one, we call it the product law. Product law. Please, when I'm teaching, make sure you are with your pen and your book. Okay, so when I'm teaching, you have to be jotting things, and it's very important. Okay, so please take note. Now, the first law is called the product law. Like example, let's say we have x raised to power a multiplied by x raised to power b. Now we call this one multiplication, right? In maths, we can either call it multiplication times or product. Are you getting it? So whenever you hear the word product, we are referring to what times or multiplication. Are you getting it? So this is the first law. It's called the product law. So let's say we have x raised to power b. Okay, these up numbers are called powers. You can either see alphabet or number. So please take note. You can either see alphabet or numbers on top. I get it. Now whenever you see a particular number or alphabet on top, we call it index numbers or index alphabet. Are you getting it? Index numbers or index alphabet, or you can call them exponents. Are you getting it? So any name I use, please don't be confused. I'm referring to the upper ones. Okay. Now we have x raised to power a multiplied by x raised to power b. Now the law states that if the two base numbers are the same, or the two alphabets, these down ones are called the bases. I get it. We have two here. One is called base, the two are called bases. Okay, so the down alphabet or the down numbers are called the bases, while the upper ones are called the exponents or the index alphabet or index numbers. So the law states that whenever we have two the same bases, so you notice that X and X are similar, right? They are the same alphabet. So whenever we have the same basis and the middle is multiplication, what you need to do is to add the upper alphabet or the upper numbers. That is just it. So what we do is we take one alphabet, since we have the same basis. Are you getting it? Whenever you have the same basis, you will take one. Are you getting it? You will take one of the base. Then if the middle is multiplication, what you need to do is what is to add up the upper ones. So we have a plus b. This is just it. I get it. It's very simple. Now let's use numbers. Let's say we have 2 raised to power 2 multiplied by 2 raised to power 2 raised to power 1. So from this product law, you will notice that we have similar bases, right? The two base numbers are the same. 2 and 2 are the same things, right? So what you need to do is to take only one of the base numbers. Then since the middle is multiplication, make sure you take note of the middle operation. It's very important. Take note of this middle operation. This middle one is very important. I get it. So since we have two equal bases, right? 2 and 2 are the same thing. So you take only one. Then since the middle is multiplication, you add up the up numbers. Are you getting it? So it will now be 2 plus 1. So we have what? 2 raised to power. 2 plus 1 is what? Is 3. So this is all the answer. Are you getting it? Now, you can leave it in this index form, or you can change it to um 2 times 2 times 2. Since we have the index number here is 3, right? We have raised to power 3. So if you want to change it to normal number, what you will need to do is what? Is to multiply this particular base number 3 times. Look at it. We have 3, right? Raised to power 3. So what you need to do is to multiply this base number 3 times. So it now be 2 times 2 times 2. So if you press your calculator, it will give you 8. Like example, you have raised to power 4. What you need to do is what? 2 times 2 times 2 into 4 times. Are you getting it? If you have raised to power 100, what you need to do is what? 2 times 2 times 2 into 100 times. Are you getting it? So this is the first law of indices. It's called the product law. Are you getting it? So let's go to the second law. Okay, so let's move to the second law. We can call it the division law. Let's say we have x raised to power a divided by x raised to power b. Now look at this operation at the middle. You know, the first one we solved, the middle was multiplication, right? But this particular one, look at the middle, is what? Division or divide, division sign, right? Now this particular one, you will still apply the same method, but the middle we have division, so the middle will change. Okay. Now we notice that the two bases are the same, right? X and x. So you will take one of the x. I get it. But yes, since the middle is division sign, I get it. Since the middle is division sign, what you need to do is to what? Minus the up numbers or the index numbers. If the middle is multiplication, you add up the up numbers, right? But this particular one, the middle is division. So what you need to do is, if the middle is division, what you need to do is to what? Minus the up numbers. So it will now be a minus b. Let's use number for example. Let's say we have 5 raised to power 4 divided by 5 raised to power 3. Okay, so we have equal to 5 and 5. 5 and 5, we have the same basis, right? So you take 1, then what? Minus the up numbers, which is 4 minus 3. To give us what? 5 raised to power 4 minus 3 is what? Is 1. And take note, any number raised to power 1, it will still give it that particular number. Are you getting it? It will still give you what? That particular number. So 5 raised to power 1, it will still give us what? 5. But in most of the answers, they might decide to leave the answer in this format. Are you getting it? So don't be confused. Any number raised to power 1, any number raised to power 1 is still that particular number. 1000 raised to power 1 is still what? 1000. 1,000,000 raised to power, any number raised to power 1, so it still give you that particular number. Are you getting it? So make sure you understand all these laws. So once you are done with these laws, in my next video, we'll be solving what? Exam and test questions. I get me. So understanding these laws will enable you or help you to solve complex questions under indices. So please follow me. Now the third law, this x raised to power 0. This particular one is very simple. Any number or any alphabet raised to power 0 is 1. I get me. Just put it in your head. Note that any number or any alphabet raised to power 0 is what? Is 1. I get me. 1,000,000 raised to power 0. 100 raised to power 0 is 1. 1000 raised to power 0 is 1. I get me. Any number raised to power 0 is what? Is 1. So take note. Okay, let's move to the fourth law. Let's say we have um x raised to power a bracket open and close raised to power b. Now look at this one. We have x raised to power a, right? Then bracket open and close raised to power this b. Now take note, when you come across this type of question, this law states that this up number Now we have two up numbers here, right? Two up, two index here, right? Look at it. We have a raised to power a and raised to power b, right? So meaning this outer one is only affecting this particular one. Are you getting it? This outer one is affecting only this one. It's not affecting this base. Are you getting it? So please take note. So it will not be x raised to power a times b is what? Is a b. Are you getting it? Let's use number. Let's say we have 2 raised to power 2, okay? Then raised to power 3. So from this law, you can easily solve it, right? So it will now be 2 raised to power what? 2 times 3 will now be 6. Are you getting it? So this outer one is affecting only this one, only the upper, not the base number or the base alphabet. So this is the fourth law, okay? So let's move to the fifth law. Let's say we have x raised to power minus a. Are you getting it? We have x raised to power minus a. Now, this law, meaning that we can change this to this format, okay? It will be 1 all over x raised to power a. Are you getting it? You know, when we are solving equations under indices, we will come across things like this. I'm using x. I can use any variable. Are you getting it? I can use either y. I can decide to use anyone. Are you getting it? But you know, in math, most times we use x, find x, find x, find x, right? That's why I'm using this one. So take note. Now, when you come across this type of thing, let's say x raised to power minus a, you can change it to this one. Now, with this understanding, let's use number. Let's say we have 5 raised to power minus 2. So from this law, you can change this one, right? It will be what? Equal to 1. This one is very important, like it's composed, you must put it. 1 all over what? 5 raised to power 2. Are you getting it? Let's say you have 2 raised to power minus 2. We have 1 all over 2 raised to power 2. So meaning that if they give you something in this form, you can change it back to this one. If they give you something in this form, you can change it back to this one. I get it. Very important. Now, um, you know, most of the answers might be in this form, but you know you can still change it, right? 1 all over 5 raised to power 2. It means what? 5 square, isn't it? So it will be 1 all over 5 square means what? 5 times 5, isn't it? When you have 2 raised to power 2, it means 2 times 2. If you have 3 raised to power 2, I think from the first law, I've explained this before. So 3 square means what? 3 times 3, isn't it? Meaning the base number, okay, multiply itself according to the given power. Now look at it. We have 5 square, so 5 times 5 will give us what? 25. Here is 1 all over 2 times 2 is what? To give us 4. Now I want to explain something. Look at this. From the first answer, 1 all over 25, right? 1 all over 25. Are you getting it? 1 all over 25. Do you know we can still change this back to this form? Yes, we can still change this back to this form. It will now be what? It will now be equal to 25 raised to power 1. Are you getting it now? 25 raised to power 1. Now, if you want to change it, it will be in this format. Are you getting it? It will be in this format. Meaning that if they give you something like this, 25 raised to power 1, pay attention, okay? 25 raised to power minus 1, okay? So it will be 1 all over 25 raised to power 1. Meaning that I said any number raised to power 1 is what? It will still give you that particular number. Are you getting me? Now this one you are adding is compulsory. Are you getting me? Converting from this particular one to this one, you must put one on top, and this is a division sign. Are you getting me? So take note of this, is very important. And supposing we have power 2 here, it will be 1 all over raised to 2, 1 all over 25 raised to power 2, isn't it? But we have 1 here. Here is only 1. We have 1 here. That's why we added 1 raised to power 1. I know that any number raised to power 1 will still give you that particular number, so no need of writing this one again. It's from 2 upward you write. I get me. If it's from 2 upward, 2, 3, 4, then you can put it here. I get it. So please take note. So I think this is the fifth law, right? Yes. So take note of this conversion. Make sure you're writing everything down though, because once we get to complex equations, all these laws we are applying them one after the other. Are you getting it? Okay, let's take note of these two ones. Now, on the first one, we have square root a, right? Why the second one is cube root a? Why the second one is called cube root a? Cube root, okay, cube root. This is the correct spelling. Cube root. Why this one is square root? Okay, square root. Meaning that from this, when you are solving, once you come across this type of square root a, what you need to do is to convert it. Are you getting it? So anytime you come across this type of law, you can convert this from square root a to a raised to power 1 all over 2. Why this one? A raised to power 1 all over 3. Are you getting it? So make sure you take note of all these laws. It's very important. These are rules or laws. Are you getting it? Governing indices. So take note. So whenever you are solving maths and you come across square root or any number inside, it can be square root 5, square root 100, any kind of number. Are you getting it? So it can be changed. Let's say we have square root 5 to be what? 5 raised to power 1 all over 2. But if it's cube root 5, it will be 5 raised to power 1 all over 3. Understood, Abby? So please take note. Make sure you write everything down. Write everything down, okay? So let's move to the next one. Let's say we have x raised to power 1 all over a. I get it. X raised to power 1 all over a. Now, if you come across, I think this is the sixth law or the seventh law. Okay, the seventh law, right? So if you want to convert this, what you need to do is draw square root, okay? Draw this root, then in maths we call the up one the numerator, right? While the down one is called what? Denominator, right? Why this one is the whole alphabet or the whole number, right? So meaning this one is what? A mixed fraction, isn't it? Mixed fraction. A mixed fraction is a type of fraction that contain what? A whole number, a numerator and a denominator. Now if you want to convert this, you will draw this square root sign, then put the denominator here, then this whole number will be inside. Look at this one, raised to power 1, right? You can write it in this one, bracket open and close, raised to power 1. But you know that any number raised to power 1 is still that particular number, so it will be a then x. Are you getting it? Let me use numbers so you understand better. Let's say we have 5 raised to power 2 all over 3. If you want to change this, you draw. Now I'm giving you guys all these laws because most of the answers you will see in the exam or test will be in this format. Sorry, will be in this format. Are you getting it? They will, like, after solving, you might come across your answer might end in a whole number. Are you getting it? But they will trying to test your knowledge. Are you getting, by converting this to this particular format. Are you getting it? So that's why I'm giving you guys all these laws. Now this 5 whole number 2 all over 3. from this explanation, I said what? You put the denominator here, right? Then the whole number will be here, which is the 5. Then bracket open and close. The numerator um will be outside the bracket. Are you getting it now? So this is how to convert, or it can be in this form. You draw your square root sign, 3, 5, then raised to power 2. Are you getting it? So it can be in this form or in this form. So take note of them. It's very important. Okay, let's move to the next one. Okay, let's look at this law. On the first one, we have bracket open y all over x, bracket close, raised to power -1. While the second one, we have bracket open and close, 1 all over x raised to power -a. Now, when solving math equations, most times you will come across this type of thing. Are you getting it? Now, I'm starting with these variables. Like, I'm starting with this y, x, all these ones. I can try to start with either z, a, any variable. Are you getting it? Now, when you are solving a math problem, and you come across this type of, like, a number or a numerator and a denominator, then raised to power minus something. Are you getting it? Like, look at this one. After this explanation, we use numbers. Are you getting it? So understand this one first. When you are solving a math equation and you come across like a numerator and a numerator divided by a denominator, then raised to power, okay, raised to power minus, it can be -1, -2, -3, -4, any number, okay, but the minus sign is there. So that is the main thing. Now, if you want to change, to remove this minus sign, because without removing this minus sign, it will be a form of, like, you'll be confused, I guess, when solving, or you might end up getting a wrong answer. So the best thing to do is to remove the minus sign. Are you getting me? So for you to remove the minus sign, just exchange the um the two numbers or the two alphabets by bringing the up one downward and moving the down one upward. When you exchange them, this minus sign will disappear. Now look at it, y all over x. So for you to remove the minus sign, it will be what? X all over y. So we are left with raised to power 1. Are you getting it? Let's do the same to the second one. We have what? By exchanging, we have what? X all over 1 raised to power a. No minus sign again. Are you getting it? So x all over 1 is what? So still give us what? X, then raised to power a. Meaning that any number divided by 1 will still give you that particular number. Let's say 5 divided by 1 is not 5. 2 divided by 1 will still give you 2, isn't it? So this is the explanation. Or any alphabet y all over 1 will still give you y. Okay, so don't be confused. Now, let me use these answers to cite example again. We have x all over y raised to power 1, isn't it? So from this first one, x all over y raised to power 1. Hope you've understood this part. To remove a minus sign, you would exchange them. I guess it. So I want to explain this here. What if you understand this? This upper number is affecting both the numerator and the denominator. So in other terms, you can write it in this form: x raised to power 1 all over y raised to power 1. Or you can change it. If you want to change from this form to this form, you put the bracket and open sign there, put this one on top. I get it. Let's say we have 2 here. So meaning you put what? 2, then put 2. I get it. But most importantly, just note that this upper one is affecting both the numerator and the denominator. That is the most important thing. So any number you see on top, note that it's affecting both the numerator and the denominator. Are you getting it? Okay, I think we are done with the laws. So in my next video, I'll be solving complex questions by using all the laws. Are you getting it? So make sure you practice these laws. Are you getting it? Make sure you understand.